All right, just coming in from the cold. I guess we don't need the hat on, except maybe to hide a balding head. All right, so this is a little practice. It's the worksheet that you have this weekend for review. We'll start with the easier problems and work our way up to about 80 problems or so, and they'll probably get progressively a little more difficult. So you can move through this video to the number that of a problem that might be giving you a little trouble. I am going to try to talk about each problem to a certain extent, how you might check to see if it's correct on your last test, if you're so inclined as to check your work carefully. Okay, so I'll move this a little closer and we'll just start and let the numbers speak for themselves because it's a language. All right, so the first problem on your worksheet is really a little distribution and addition and subtraction of like terms. And we'll make a statement here as to what this equals. And then we'll put the number 1 in for check. So when I get here, we can look at the number 1 easily because it's the coefficients. Right? So this was going to become, if x is 1, this is -5 times 2 plus 4 minus 3 minus 2 times 1 minus 5 plus 12. We'll do that quickly. So x is 1 here. So we got 6 minus 3 is 3. So this is -15. Over here we got 13 minus 5 is 8 times -2 is -16. If I didn't make a careless error, -31 better come out of whatever we say this is simplified as. If it's the same, then it works for all numbers. So -5x times 2x squared is -10x cubed. Counting properly, right? 1 and 2 make 3. Three-dimensional picture. -5x times 4x is -20x squared. -5x times -3 is +15x. -2x cubed. -2 times -5 is +10x. -2 times 12 is -24. Let's put our like terms together, and I'm assuming that'll be our final answer. X cubes, I see -12 of them. If you don't, keep looking at it till you do. I don't see any other x squared, so -20x squared. 15 plus 10, I'm seeing 25x. And I'm seeing one constant, -24. So let's throw the number 1 in. -12, -20, plus 25, -24. Why don't we do this right here? That's +1. -12 minus 20 is -32 plus +1 is -31. I guess we didn't make any mistakes, and that's our final answer. It's easy to make a mistake, especially with the first problem on a test. You're anxious, ready to take your last test of the term. Might be a good idea to check it with a number. Easiest one you can think of. All right, 4x plus 5, x minus 2. It's just mechanics. So 4x times x, 4x squared. 4x times -2, -8x. 5 times x, 5x. 5 times -2, -10. I retract my earlier statement when I said it's just mechanics. There's a whole lot more going on than that. Looking at this, it's a product. We have been studying products in class from various perspectives. 4x times x is 4x squared. We've been talking about quadratics and cup shapes up and down. So looking at that, you should immediately see this, and you should immediately see that 2 gets you a 0, and -5/4 also gets you a 0. That's what's given as a gift. Given gift. Anyway, final answer for this is simply 4x squared. -8 plus 5 is -3x, and -10. Once again, the number 1, I'd use a 2. 2 minus 2 is 0. 0 times anything is 0. We already knew that, right? So if this is true, then that multiplication gives us this, then 2 should get a 0. So that's 16 minus 6 minus 10. There's 10 minus 10. There's your 0. You move on. Okay. And you don't even have to ask anybody if you got it right or wrong. You just prove it to yourself. Well, it's not proof. I mean, it's supposed to work for all numbers. I don't think we used all the numbers in the world. But for a test like this, move on. So we're looking at the equation of a line. I wrote it this way because it's possible that you could, in haste, get your x's and your y's mixed up. All right, so the change in y over here, how do I get from 8 to 3 down 5? How do I get from -7 to 4 up 11? I should write y equals, I suppose. But, you know, we're putting it together. How do I turn a -7 into an 8? By adding 7. It's gone. I want the number 8. I just write it. I don't think I'm telling you anything that anybody can't do at this point in time. I think pretty much everybody's got that down. Okay, could you see that? Did I? Yeah, we're good. All right, so we got number 4. It really wasn't number 4. It was given 2 functions. This calculation is referred to as f of x, and this calculation is referred to as g of x. And we're trying to find g of 7. And g of x, g of 7, I guess 7 is an x value. Yeah, looks like 7's an x value. And what do we do with x values? We use them. So that's -5/2, 7 plus 7, which is equal to -35/2 plus 14/2, which is equal to what? Take 10 away, 25, 4 more, so -21/2. Okay. So let's graph this critter real quick. That's in slope-intercept form. 7 is y-intercept. I'm going over 2 units down 5. That probably put me about there. I'm going to graph that. And it sure looks to me as though if this is the x-axis, 7 is probably over here somewhere. I'm getting a bit of a negative number out. Looks good to me. So I don't think I made any mistakes because I checked it, you know, from a different perspective. And it seems to match. So I'm feeling good. I think I got 4 problems right so far. I don't think I've made a mistake yet. I rarely check my work this much, but since it's the end of the term, I guess it's time. So f of x equals 4. Well, that's f of x. It's this calculation. So I guess we're setting it to 4. I guess I'm adding 1. I guess I'm multiplying by 3. I guess I'm dividing by -5. I know 5 goes into 15 3 times. I think -5 goes into 15 minus 3. So why don't we check that the same way we did the last one? Okay, which one am I at? That's slope-intercept. So my intercept's -1. Let's call that 1 unit of change. I'm going down 5 over 3. That probably take me about there. And I am looking for when this hits a height of 4. Well, that's 1 unit, so 4 is probably up here, y equals 4. So I connect the dots. I've got an x that appears to be negative, and it appears to be around -4 as an answer. So, oh, -3. I'm feeling good. I'm feeling good. I don't think I made a mistake yet. So that's 5 problems because there was no 4. That was a fictitious 4. Okay, and I learned something new today. That if I don't check made for children, anybody under 18, people can make comments on the videos. Be interesting now that I know that I can allow comments to be made. And maybe somebody, you know, over in Azerbaijan, I can't even say that right now, I'm so tired, might want to write to me and say, hey, I don't believe you. Oh, no. So log base 8, that means I'm looking for that. I'm looking for an exponent on top of 8 that's in this parentheses. And I know that parentheses can be written as 1 over 8 squared. And I know that parentheses can be written as 8 to the -2. I got a feeling x is -2. Nothing else I can say about that. We talked about where negative exponents come from week 1. All right, so if I have some number like 2 times 2, and that's probably not the one well, and I have 2 times 2 times 2 times 2 times 2. Well, that's 4 over 32, and that's 1/8. Okay, and it looks like I have 2 to the 2 in the numerator and 2 to the 5 in the denominator. And that's 2 to the 3 in the denominator, which is 1/8, and that's the same thing as 2 to the negative 3. And minus 3 means this. I don't know what else to say about that. It's Friday late afternoon. I said enough. All right, so now we're working on number 9. Whatever. Number 9. Oh, it's a good thing I know what I asked. I think I know what I asked. If there's no directions there for this, I'm guessing I asked 3 points. Okay, which means that you might want to think of it this way, put the y over there. I think maybe that would be a better way historically if folks wrote things, because then it appears like X gets Y. Input gets output. So what number is being begged to be used? 1. Why? Because that's a product. And it's very helpful to make products equal 0. And 1 makes that happen, so you get 27. And then it would be nice if, you know, this parentheses had a 9 in it. That would be nice, because that's an easy calculation too. So I think I want 10. And if we do that and do the math, minus 20 plus 27 is positive 7. It sure looks like this went down 20. It sure looks like this went up 9. I wonder where I could see minus 20 and 9 in this. Oh, it's right there. Okay, now I know 95% of you know that already. So this conversation is for the 5% of you that haven't picked that up yet. Okay, this is your last shot. All right, so I got a feeling all of these numbers are very nice. 20, oh, make me think, minus 7, minus 17. God, my brain is really tired right now, that's wrong. So down 7, down another 13, huh? So minus 13, 7 to 0, 0. Yeah, okay, that's better. And now minus 20. Oh, that's good. That's a little easier. So if I put 28 in, I should get negative 3 out. So let's just check it. 28 minus 1, 27. Oh, I like that. I like that. 9 goes into 27 3 times. 3 times minus 20 is minus 60 plus 27. Minus 60 plus 27, which is the opposite of 60 minus 27. Check. Oh boy, am I going to get through this video? I hope so. I'm really starting to fade. All right. That's because I've been doing it since 5:30 this morning. Okay, so I don't like dividing by negatives. So I'm going to bring that this way, and I'll bring the minus 2 that way. And hopefully you've been paying attention and you can see why that's 28x and why that is negative 12. And so therefore negative 12 over 28 equals x. We should reduce that. What, 4 goes into both? So minus 3 over 7. And we should check it graphically. All right, another slope intercept. So negative 14 will make this negative 14. And we're going down at 23 to 1. No, that's really steep that way. Okay, that probably doesn't even do justice to the cause. 5x minus 2, if that's minus 14 minus 5, minus 2 is probably there. Over 1 up 5, over 1 up 5 puts me here. Looks like I have a very small negative number. Check. Seems right to me. Just showing you ways you can check your work. Woo. All right, so I want to multiply everything. It's problem 11. I want to multiply everything by 15. Just to, you know, let's look at 1 plus 2 equals 3. Let's multiply everything by 10. 10 plus 20 equals 30. Looks like I can do that. Let's call 1 this time. Let's call it 3 over 3. Let's call 2 6. No, not over 3. Let's call it 4 over 2. This should still get me 30 when I multiply by, can't multiply by 10. 3 and 2, I'll multiply by 6. Yeah. All right, so new situation here. So we still started with 1 plus 2 equals 3. So we should get 6 plus 12 equals 18 as our middle step. All right, let me erase. And how do we do it? Well, 6 times 3 is 18, and 18 divided by 3 is 6. But you know, I don't think we want to go that route. I think we want to go 3 into 6 is 2, and 2 times 3 is 6. Instead of getting bigger and then smaller, get smaller then bigger. Just a little easier. 2 goes into 6 3 times. 3 times 4 is 12. So 6 times 2 goes into 6 3 times, so that's going to be 12. And 6 times 3 is 18. Okay, so now that we know that, that's why we picked the number 15 up here. So let me do this so it doesn't look like problem 15. So we're going to multiply every term by 15. If we do, we know we're equal. And we're going to get rid of division by 5 and 3. So 5 goes into 15. 3 times 3x is 9x. 15 times minus 2 is minus 30. 3 goes into 15. 5 times minus 4x is minus 20x. And 15 times 2 is 30. All right, I'm going to bring minus this way, so that's 29x. I'm going to bring minus that way, that's 60. So your answer is 60 over 29. And I'm not checking anything anymore because I'm too tired. All right, so perpendiculars, let's get a perpendicular. Let's say that's 5 units and that's 1. So that slope is 1 over 5. Let's draw a perpendicular. I'll do it by. That's close, I think, I hope. And it sure looks like I'm going over 1 and down 5. So the perpendicular slope is down 5 over 1. Is there a relationship between 1 over 5 and minus 5 over 1? I think if we can find the original slope, I think we can figure out what the perpendicular is. All right, so this number doesn't matter. It has nothing to do with rates of change. So what's the easiest way? Don't divide by a negative. Some of you are still making a lot of mistakes. You got to know how to do that, but why don't you move it first? All right, how do we get y alone? Dividing by 17. There's our multiplier. Our original slope is 11 over 17. So what is our second equation? If one line is going up, the other is going down. If that's a positive slope, that's a negative. Got to change the sign. It's got to be negative. And rise and overrun switches. We want it to go through negative 1, 4, and x plus 1 plus 4. Check. Okay. Let's hope I don't make mistakes now, because a little daffy. I guess we can see whatever I asked here. Ooh, f of negative 3. This is purely to find out, to make sure that you can work with fractions easily, work with sign changes easily, and add and subtract and multiply and divide fractions easily. So let's hope that that has happened this semester. So the first thing we're going to do is move this over because it's going to take more space. 5 fourths times negative 3 cubed plus 2. That's an odd exponent. So we're going to do negative 3 times negative 3 times negative 3. 3 negatives make a negative in multiplication. And it's not 3 times 3, it's not 9. So 5 fourths times negative 27 plus 2. I got a feeling that's going to turn into 8 fourths. Minus 135 fourths. Plus 8 fourths allows us to add fourths. And take 8 away from 135, and you got what? I knew that brain was gonna stop working. 127/4. Okay, if I'm wrong, I'm wrong. Not thinking about it again. All right, inverses. You gotta know what the notation means. That's why it's a language. If you don't understand what it's asking, then you can't deal with it. So we're looking at inverse of this function. And really inverse is a function, how you solve equations. So let's just make an equation here and just pretend that this thing equals, oh, I don't know, about 12. Okay, let's just pretend it equals 12, but let's let 12 be represented by the letter x. Because this is gonna be a function we put into a calculator. So how would I solve that? Well, -2 would become +2 on the other side, right? You'd be moving that over. You'd be dividing by 5. And logs are the inverse of exponentiation, and the base in this problem is 3. So that should be my inverse. Now, let's put an easy number in here. How about we put 3 in here? 3 plus 2 is 5, divided by 5 is 1, and 3 to the 1 is 3. So in this equation, g minus 1 of, what did I plug in? 3 gets me 3. Looks like it does. So up above, a 3 should get you a 3. So let's put 3 in. What is the exponent put on top of 3 to get a 3? 1 times 5 minus 2 is 3. So it works. Let's make this a 2 this time. So let's put 8 in here. Right? I think that's a better number. So if we put 8 in there, we get 3 squared, which is 9. Which means that g of 9 has to come back as 8. I think it would be nicer to do that. So let's put a 9 in. Right? So what do you put on top of the 3 to get a 9? A 2. And 5 times 2 is 10, minus 2 is 8. Check, move on. I suggest you do that on these problems, that you check to make sure you're not making a careless error. All right, what to 16 to the what equals 4? I'm hoping everybody, yeah, you can see it. I'm hoping everybody knows that the square root of 16 equals 4, and 16 to the 1/2 is another way of writing the square root of 16. So I hope you're just answering it by saying x is a half. But many of you haven't got there yet. So you got to write this in base 4 notation. 16 is 4 squared. We're raising it to the x, and 4 is raised to the power of 1. Hope you know your rules. That's multiplication. 4 to the 1. 2x equals 1. And hopefully you can see how you got there. I can't think of a way to check that right now. I mean, you could graph it, but if you're graphing it, you know what the graph looks like, then you don't need to graph it because you're sure of your answer. All right, x squared minus 10x plus 5, completing the square. Yeah, that's a fancy term for put it in graphing form. Right? If for no other reason, I mean, I'm hoping that you know how to do that quickly. And we've practiced it enough. But if you don't, completing the square is all about minus b over 2a, okay, which in this case is positive 10 over 2 times 1. We don't write the 1 here. All right, and what do you get? 5. Okay, so I hope you understand why you're writing x minus 5, because the smallest area square can be a 0. So there's geometric reasons. All right, and so we get a minimum here at 5 comma negative 20. Okay, so final answer should be x minus 5 squared minus 20 is the same thing as x squared minus 10x plus 5. Geez, I wonder how we can check this. Can't imagine how we can check this. Oh, that's right, put a number in. Let's let x equal 5. Oh, that goes. I get an answer, a y value of minus 20. So over here, if I put 5 in and it doesn't come out as minus 20, I made a careless error. So 25 minus 50, oh, I like it already, plus 5, minus 25 plus 5. I don't think we have to go any further. Sure looks right to me. All right, so what can I say about number 17? Well, many of you know how to do that. Most of you know that 10 plus 2 divided by 2 is equal to 5 plus 1, 6. 12 divided by 2 is 6. You can't do that because division doesn't undo addition. Another way of saying this that might help for folks who still are trying to figure out what's going on. 1 over 20x to the fourth is another way of saying division by 20x to the fourth. So this is also true. And I hope you can see the distribution now of the division. All right, so how do you reduce 15 over 20? Well, 5 goes into both. So we know we got 3/4. What's x to the 6th over x to the 4? It's x squared. Now we gotta do the second fraction. And 40 divided by 20 is 2. So we got a -2. X to the 8 over x to the 4 is x to the 4. Hopefully you know to subtract, right? Because all you're doing is counting. 6 x's, 1, 2, 3, 4, 5, 6. 4 in the denominator, 1, 2, 3, 4. What is this division? Something by itself equals 1. 1 times x squared. That's why that is what it is. So hopefully you're taking 6 minus 4 and saying 2, and 8 minus 4 and saying 4. Okay, so we're basically doing some fundamental work here. And the problems are going to get progressively harder as we move along. And we'll see how many of those you can do. So difference of 2 squares, 9x plus 2, 9x minus 2. We've looked at that enough. I'm not going to, yeah, I can probably just look at 25 minus 4 as being 5 plus 2 times 5 minus 2, which is 7 times 3, which is 21. This is 21. Hopefully you can see the square roots, right? The square root of 25 is 5. The square root of 4 is 2. So the sum of the square roots times the difference. That's what we've done here. Enough said. Getting tired. All right, squaring a binomial. You've had it now on, I'm guessing 10 to 12 tests. All right. 5x minus 3 times 5x minus 3. You do that on your own. I'm just going to take the shortcut. So 25x squared, doubling that product, minus 30x, squaring the last term. There you go. Put a 1 in. 5 minus 3 is 2 squared is 4. If you put a 1 in, you get 4. If you put a 1 in, you get the coefficients. 25 minus 30 is minus 5 plus 9. There's your 4. Okay, you can check it if you have to, but hopefully you don't have to do any of that, and you're just confident in that answer. All right, square root of 6 times the square root of 30. I guess you can see it already here. Yep. So we started this discussion with 2 times 3 equals 6. And then we said 2 is the square root of 4, 3 is the square root of 9, 6 is the square root of 36. Okay, so a square root times a square root is a square root. So we also looked at 9 being 3 times 3, right? And this is a square root. But we wrote 3 as the square root of 9. And this 3 is the square root of 9. So the square root of 9 times the square root of 9, it's got to get you what's inside. So the square root of 5 times the square root of 5 has to get you what's inside. How does that help us? How do all these comments help us? Because hopefully you can see that is hiding inside here. Running out of ink here. And so we distribute, not distribute, we associate those. What's the word to look at? Pair them up. Square root of 6 times the square root of 6. That brings us back to this discussion. And that's 6. So this answer is 6 root 5. All right. You're also supposed to know at this stage your perfect squares, your user-friendly squares. 4, 9, 16, 25, 36, etc. All the way up to 100. You got to know those. Any of these numbers hiding in there, of course. Square root of 4, square root of 7. One of those is a nice square root that can be simplified. Hopefully at this stage, you're saying that. Okay, so that, if you did this on a calculator, you would get the same answer as if you did that. Not very helpful here, but if you memorize the values that I asked you to on your memorization sheet, we're running out of time, so we're not quizzing you on it. Okay, it happened. Okay, because we got to test you a lot the last 2 weeks to give you a chance to learn from your mistakes and raise your grades. Square root of 2 is 1.41 times 3, and that was probably, that's an approximation, but that's probably pretty helpful for folks when they didn't have calculators, computers, knowing some of those square roots. All right, so now I'm going to do 4 graphs quickly. You will have probably 10 to 12 graphs on each of your next 5 tests. So 45, roughly 45 problems one day, 45 the next, combined score. But we will be Xing out those problems that you get twice in a row right. So each test will be less and you won't be as crammed for time. And you shouldn't be anyway. You should be able to do 45 problems probably in 30 minutes. I'm guessing, you know, if you saw that, you probably could write or graph this, a lot of you in probably 15 seconds. Okay, so let's just do it. Slope intercept form, intercept +5, you should label 0, 5. Or over here, I don't care, as long as you do something, I know you're looking at that point. And you should know how to go over 2 units and down 3 as a ratio. We could have gone over 20 and down 30 as a ratio. Back, we could have done the same thing, the 2 to 3. Anyway, we're connecting these. That's fine, as long as you label over 2 and down 3 somewhere, or some kind of ratio, 2 to 3, we'll accept that. You could have also realized that if this is 1 point, then this changes by 2, 4, 6, this goes down by 3, -1, -4, so on and so forth, and plotted some of those points. So this thing is looking like that. It's going to negative infinity for range, positive infinity for range, and left and right forever. Right? If I went over here, there would be a place on the graph. So your domain is all reals and your range is all reals. But you've got to say domain are the x's and they are equal to all the real numbers. Range, show us you know it's the y's. Okay. All right. So linear functions, domain and range are all reals. Not going to spend much time on this. It's a product. You make product 0. So y is -4. That's the y-intercept. 0, -4. Minus signs mean it's going up. If it's a subtraction, it's going up. Addition means it's coming down. Just saying it. If you let y equal 0, cover it up. X is 12. Well, maybe out here. So 12. So this is called standard form. Standard form. You're not supposed to change the way it's written. You're supposed to know that it's the x and y intercepts. Again, domain and range all reals. Okay, point slope over here. Point slope. And if you're having any trouble with it, move the 2 to the other side. Might help you. Minus becomes plus. Okay, so we can immediately see 4, 2. So let's say that's 4 units. And then 2 would be there. So you're 4, 2. And we're doing what? Going up 5 over 3. Rise over run. Oh, that was poorly drawn. There, maybe that's a 5 to 3 ratio. But because we're going through the x and y axis, yeah, I'm not gonna. So let's just get one more point there. So over 3 and up 5 from, let's write this 4, 2. So if I go over 3, then I'm at 7. And if I go up 5 from 2, I'm at 7, 7. Let's just check it real quick for you. 7 minus 4 is 3. Oh yes, multiples of 3 are so much fun. And 5 plus 2 is 7. So connecting that, domain, again, all reals, range, all reals. All right, 4 steps here, 4 steps. First step, it's positive. X squared, cup shape up. That's going to be worth a half a point on a test, knowing that it's cup shape up. Okay, second step, finding the x value that's important. Minus b over 2a does it, which is minus 12 over 4. 2 times 2 is 4, so -3. Step 2, So that's a half a point, that's a half a point. Step 3, find out what goes with a -3. Find the y value. -3 times 12, -36, cut in half, -18, -5, -23. That was the shortcut. If you don't take a shortcut, -3 squared is 9 times 2 is 18, -36 -5, 18 -36 is half of that, -5. And that always happens when they're opposites. Okay, so there's your -23. You're at a 1.5. Please try to figure out where 0 is. 0 is an x value. X values go side to side. We know where this x is. So hopefully you are correctly putting 0 on this side. Okay, and so -3 gets us -23. 0 gets us -5, right? If you plug a 0 in, that term disappears, that term disappears, gets you -5. Now, somewhere on the test, if it's not there, it will be. I'm certainly going to give you something like this and say, get back to this. And how would you do it? Well, we know that for certain, right? And then we're going to say, well, I moved 3 units to get to 0, and I square them. If I square 3 units, I should go up 9. But 9 minus 33 does not take me to -5. No, so we get rid of that 9 units and we say, well, how far is it from -23? I made a mistake. No, I didn't make a mistake. How far is it from -23 to -5? It's actually 18 units. Oh, 18 divided by 9 is 2. X plus 3 squared is x squared plus 6x plus 9. -31, 2x squared plus 12x. Oh, well, that's kind of nice. 2x squared plus 12x. And I got 18 minus 31, which is not right. So what did I do? I did something stupid. Oh, this was 23. Oh, wait a minute. Yeah, that was what I did stupid. All right. I knew I was going to crash here at some point. All right, so how do I get from -23 to -5? I got to go up 18. Okay, so this is now right. And where was I? Oh, yeah, 2 times 9. This is -23. Excuse me for being crashing here. So that's 18 minus 23. And yes, that's -5. Boom. Okay, so hopefully if that's not on the test, it's getting added, right? Because we spent a lot of time on that in the first couple of weeks of the term. Woo, I'm tired. All right. That's 21 problems or so with a lot of talk about each problem. Hopefully it helps you if there's any of those you don't know how to do. They're going to get progressively worse as we do the next 20. And not worse. Why did I say worse? I better be quiet and just stop this. Bye-bye.